In this problem, we're being asked to calculate the atomic weight of an unknown element and identify what that element is. They give us two values of weight here. They give us half a gram for xi3, and 0.2360 grams of xCl3. So that's really what we're concerned with here, our xi3 and our xCl3, because that's what they weighed for us. So let's first look at the moles, because moles are the basics of chemistry. This has 2 moles. And this also has 2 moles. So that's a similarity. And those two are equal in that sense. They both react 2 moles and will produce 2 moles. Their mole-to-mole ratio will be 2 to 2 or 1 to 1 if you divide both by 2. So that's great. And let's see, what are we given here? We're given that this is 0.500 grams. And we're given that this is 0.2360 grams. I need to calibrate my pen after this video. So from this, remember, we always need to put units. And from here, we're going to be able to find the moles of our element X and the moles of our element X, and we're going to be able to compare those to be equal to each other, as in our balanced equation, which is very important. So let's move along to the steps, shall we? So just as a reminder, we're given 0.5000 grams of our X13. Now, we want to find the moles of this substance. So what we're going to do is we're going to put mole on the top, because our numerator is not going to be canceled out. We want to cancel out the grams. So we need to find the molar mass of X13. Now you might be wondering, how do we do that? We don't know the atomic mass of X. That's what we're trying to find. So we're actually going to keep that as a variable. We're going to keep it as X, but we do know the atomic mass of iodine. And if you multiply that by 3, go ahead and try on your own and pause the video to try and find the molar atomic mass of iodine 3. If you do that, you'll find that you need to do 126.9 times 3, and then you're going to find it to be 380.7 grams of Xi3. From there, you can cancel out the grams, and you're going to be left with the moles. But we're not done yet. We found the moles of Xi3, but we're just trying to find the moles of X. So we're going to do some dimensional analysis here. We know that 1 mole, that's what we're trying to cancel out of Xi3, but we're trying to find X. So in Xi3, per 1 mole, there's also going to be 1 mole of X. So we can add that to the numerator. If we were doing iodine, on the other hand, we would add 3 moles of iodine, but we're doing X, and it's only 1 on the bottom. So there we have it, 1 mole of X. We're going to go ahead and cancel those out, and we're going to be left with our unit that we want. From here, it's going to be 0.500 divided by X plus 380.7. And that's going to give us what we want. Let's move on to the next step. In this one, we're going with the xCl3. We did the Xi3, and now we're doing the xCl3. We know that we have 0.2360 grams of it, and we want to find the amount of that in moles, and we already know how to do that. We're going to do 1 mole of the xCl3 on the top, because that's what we want to find. And on the bottom, we want to cancel out the grams. Again, we don't know the atomic mass of X, but we do know the atomic mass of chlorine. When you multiply that by 3, you're going to get 106.35. So similar to the process we did here, actually. But we don't want the moles of XCl3, we want the moles of X only. So we're going to cancel that out like we want to. And again, this has a 1 on it. So it's going to be 1 mole of X. And that's going to give us what we want, right? The moles of X. So once we multiply that all together, we're going to get 0.2360 divided by X plus 106.35. And that's going to be our moles of X. And this is also going to be our moles of X. Moles of X, moles of X. We know that they have to be equal to one another. So that is really, really useful for what we're about to do. Since they're equal to each other, we're going to set them equal to each other, just like they are, and that's going to enable us to calculate X. So we have 0.5 divided by X plus 380.7, and that's going to be equal to this right here. Those two are going to be equal. So it looks like it's a good time to do some cross multiplication. So let me get back to my paintbrush. We're going to do some cross multiplication. And we're going to get 0.5 times X plus 106.35 is going to be equal to 0.2360 times X plus 380.7. And those two are going to be equal to each other. Once we multiply that out, we're going to get 0.5x. We're going to use the distributive property. And if you get half of that, it's actually going to be equal to 53.175. Again, the distributive property, 0.2360x. And we're going to add that to 89.8452. That's what happens when you multiply this by this. So let's combine our like terms here. It makes sense to subtract this over to the other side. And once you subtract this from both sides, you're going to get 0.264x. By subtracting this from both sides, you're going to have that equal to 36.606702. And we want to isolate x. So this is just simple algebra divided by 0.264 divided by 0.264. And you're going to get x being equal to 138.9. And that is our answer. We found the atomic mass, but we still haven't identified it. So let's look at our periodic table and let's search through and see which one has an atomic mass of around 138.9. And after looking, you'll see that the element is this. And that is the answer to our question. Great job. So now, just for a little bit of review, what we did was we looked at our balanced equation, which is very important. We found that it's a 1-to-1 mole ratio, which means that these two are going to be equal. But first we needed to find the molar mass of both. So we were given half a gram of XI3, and we converted that to moles of X through dimensional analysis. We did the same thing for 0.2360 grams of XCl3, and we converted it to this with dimensional analysis. Since we know these two are going to be equal, we set them equal to each other. We used cross multiplication and did simple algebra to get to our X value being 138.9 atomic mass units, and looked on the periodic table to find that that element is A. And that solved our problem.